me great pleasure to introduce our first keynote of the day, Dolf Gielen, Director of the International Renewable Energy Agency's Innovation and Technology Center. As Director of the IRENA Innovation and Technology Center since 2011, Dolf oversees the agency's work on advising member countries in the area of technology status and roadmaps, energy planning, cost and markets, and innovation policy frameworks. Before joining IRENA, Dolf was Chief of the Energy Efficiency Unit at the United Nations Industrial Development Organization. Late last year, Dolf co-authored a report on the gas crunch in which he asked the question, if we had invested more in renewables, efficiency, buildings, renovation and green gases, would we be actually saving money instead of losing it? To which the answer, of course, was an emphatic yes. Now, as the world reels from the impacts of Russia's invasion of Ukraine, countries are waking up to the need to future-proof our economies against fossil fuel volatility and all its costs. And how this volatility should act as the spur to rapid investment in green gases, biogas, biomethane, and green hydrogen. So just for those of you who are joining us virtually, please remember that you can ask us questions in the Q&A tab to the right of your screen, and obviously all of you here, just raise your hand at the end and we will bring a mic to you. So Dolf, welcome, and over to you.
Yeah, thank you very much, Charlotte. It's a great pleasure to join today, and good morning or good day to everyone. Can you see my slides?
Yes, we can.
Excellent. Good. So this is a very important summit because biogas and biomethane are really key parts of the energy transition going forward. I'll show you in a minute. In our scenarios, we have biogas growing 12-fold this decade. That is what would be needed for a 1.5 degree pathway. And let's say the drivers for this transition, especially in Europe, have of course changed in recent months. Was it initially mainly CO2 and methane emission reduction? Nowadays, the security benefits and replacement of natural gas has become also a key part of the energy policy objectives. And of course, biogas and biomethane especially can play a role in that. Now, we do quite a lot of work on biomass, and we always get two types of questions. One type of question is there enough biomass available? And our answer to that is yes, but so we have a lot of discussions around that. And the second type of questions is around what is now the optimal use of the available primary biomass. And so we think that biogas is a very important part of the application. But also there you need to look into the specifics of the power system, what is now of the energy system, of what is now the optimal use, because it's a very diverse resource. You can use it for dispatchable power, you can use it in the gas grids, you can use it for road transportation, you can even use it to produce ammonia, so plenty of opportunities there. You need to think through what is now the optimal use. Now, in terms of the drivers, so as you're all aware, the recent gas price increase, especially in Europe, has changed the economics a lot. Natural gas globally, the use is about 4,000 BCM. and around 1% at the moment is biogas or biomethane. Europe is part of that global market. The European market is in the order of 10-12% of the total global natural gas market, with a falling share of indigenous natural gas production. And that's then where biogas can come into play. So biogas and biomethane accounted for around 4.6% of total gas supply in Europe. But in some countries, it's already much higher. I show here a graph as an example for Denmark. So Denmark last year, 25% share of biomethane in the natural gas system. So it's much higher. Of course, Denmark is on a European scale a relatively small market, but the bulk of Germany, for example, accounts for half of total biogas and biomethane in Europe. And in a European context, about 2/3 of the supply is based on agricultural feedstocks. And so the markets vary a bit. In Denmark, it's mainly going into the gas system. In Sweden, for example, the use in transportation dominates. So gas price natural gas price around 80 euros per megawatt hour, the TTF price, which is let's say a wholesale price. If you look at the biomethane prices, I show you here as an example prices for Germany. These are prices for biomethane produced from residues. And so the price range is 90 to 110 euros per megawatt hour for delivery early next year. And so that's slightly above these gas prices. You see also that the prices have increased over the last year somewhat, but nowhere close to the price increase we've seen for natural gas. So slightly above that price, but so the biomethane price slightly above the natural gas price, but not much above. And of course, it depends also a little bit on the feedstock. So for different type of feedstocks, you find prices starting from 55 euros per megawatt hour. In 2020 European case, there was around 18 BCM of biogas and biomethane produced. That was around 15 BCM of biogas and around 3 BCM of biomethane. So biomethane is still only a fraction of the total biogas market, but it's a rapidly growing share. Now, in a global context, I looked into our statistics. You can find them on our website. There was last year 21.6 gigawatts of biogas power capacity worldwide, and there was around 100 terawatt hours of power produced with that capacity. So that compares to around 8,000 gigawatts of total installed power generation capacity worldwide, and it equals around 0.3% of all power that was generated worldwide. So the US is the largest, has the largest installed biogas power capacity with around 2.3 gigawatts, followed by at least outside Europe, followed by China. You see that Germany is by far the largest, has by far the largest installed capacity. And so Europe is a leader in worldwide biogas and biomethane, with more than 1,000 biomethane plants and 20,000 biogas. So as said, there are a number of markets. There is the important power market, there is the transportation fuel market, so CNG and LNG. There's also let's say the gas grid market, and there is the cooking market. And cooking in a global context is an important issue. This graph shows the progress that has been made in clean cooking in recent years. But in 2019, according to the latest statistics, SDG update, there was around still 2.6 billion people cooking with traditional fuels. And business as usual would take that to 2.4, while the objective, SDG objective, is everybody access to modern cooking fuels. So in that context, biogas can also play an important role. And these two graphs show you the trends for biogas cooking. So roughly flat in Asia, around 120 million people using biogas for cooking, and a growing use of biogas in other parts of the world, notably in Africa, but of course the levels are much lower than in Asia. So around 400,000 people using biogas for cooking. So there is a significant growth potential going forward. So as said, I mean, there is a range of feedstocks that is deployed and that can be deployed. It depends a little bit on the country circumstances, where the largest potential is. And the potential to grow biogas is still very significant, as it's only 1% of natural gas used today. There's a number of studies around for different parts of the world that suggest 10 to 20% of gas, total gas supply is certainly possible. If you take a larger share of the overall biomass availability going to biomethane and biogas and biomethane production, of course, that percentage can grow even further. And so we have developed our own 1.5 degree pathway, part of the World Energy Transitions Outlook. Here you see how we see the energy, final energy demand developing in that pathway. So total final energy consumption would slightly fall, while global economy grows 2.5-fold, so significant efficiency gains. But you see that the role of modern biomass, including biogas, increases significantly in this final energy use, from 3% to 18% of total final energy consumption. And this graph shows how the final bioenergy use develops. And you see also biogas and biomethane indicated here in this graph. So 2019, about half of total biogas use went into final energy. The remainder went into power. That would grow from half an exajoule to around 6 exajoule 2030. So that's a 12-fold increase. At the same time, the use of biogas for power also increased significantly. So we see a key role for biogas in energy transition going forward, with a lot of action in this decade. And so this graph shows then the primary biomass use, and you see also here on top indicated what part of the primary energy use would go to as feedstock for gaseous biofuels or biogas. And we see total biomass use, primary biomass use, grows significantly in this pathway. Nearly threefold to around 150 exajoules. And out of that, around 25 exajoules primary biomass would go to gaseous biofuels. So, which then gives you around 10, 15 exajoules of biogas. And then half of that would go to power, half of that would go to final energy use, either as biogas or as biomethane. And here you see the breakdown of how the use of renewables in end users would grow. This is only the direct use of renewables. This excludes, of course, renewable electricity use, which would also grow significantly. So the biofuels overall would grow significantly, fourfold. And out of this 22 exajoules of biofuels in 2030, there would be around 6 exajoules of biogas and biomethane, so about a third or a quarter. So significant role of biogas overall in the energy transition. And we've broken that also further down into biomass used then for buildings, for heating and cooking, as well as for industry. So we think that both shares would grow roughly equally going forward. As said, these numbers are subject to significant uncertainty. I mean, this is a scenario. This is a normative 1.5 degree pathway. Of course, there's a significant effort needed to be on this pathway, and as said, where exactly that biomass will be allocated and what is the best use also depends on the development of a number of other technologies. For example, how much of biomass will be used to produce liquid biofuels for road transport and also for shipping and aviation depends also a bit on the development of other direct electrification and synfuel production routes. So it's for sure that there will be a need for significant growth, but the absolute amounts longer term are still subject to some uncertainty. It will also depend on what is the innovation in all these different technologies, to what extent is a modular approach possible, to what extent can this rapidly be scaled up. And for all the biomass pathways, the key question is how much sustainable, affordable, and reliable biomass feedstock will be available long term. That is the key question for all these biomass solutions, including biogas and biomethane. As I said, we have a lot of discussions around this feedstock availability question. So in summary, a key role for biogas and biomethane going forward. Feedstock being a key question, and competing uses of that feedstock. We see half of biogas going to end use, half going to power, and significant growth up to six-fold growth in a 1.5 degree pathway up to 2030 at a global scale, with, of course, differentiated developments in different markets depending on the energy policy priorities. So that concludes my presentation. Thank you very much.
Thank you. 10 minutes. Thank you, Dolf. That was very interesting indeed. And I think the whole question of availability of the sort of the feedstock that would go into generating biogas is definitely something that there is a lot of questions about. As you know, we've done a lot of analysis which quantifies the available feedstock at around 105 billion tonnes. Because there's a slight nuance here between the feedstock that is technically there and the costs of extracting it and putting it into AD. So at what point do you say that it's economically viable to put that into biogas? But obviously that's a question of how we adjust the pricing, I suppose, to ensure that we get the right outcomes. So we have the opportunity to, all of you audience members, both here present and virtually, have the opportunity to ask questions for Dolf. Do we have any questions from here now? And we can get the mic to you. We have great Roberta. We have Roberta here from the Roberta Cheney from the Maersk Moller Net Zero Shipping Center. Roberta.
Good morning, Dolf. I was wondering, in your estimate, what is the role of electrification in the residential use of energy? Would you foresee that in Europe, probably this is going to become more and more affordable for most countries? What would you see the trend being worldwide? I could see the trend in biomass consumption for residential purposes going up to a certain extent and then down again. Is that because it is replaced by electricity, or are there other considerations?
Yes, so there are a number of different, let's say, market segments. Today, the bulk of the biomass going into residential use is for cooking. It's traditional biomass going for cooking. So in this scenario, traditional biomass is replaced with other cooking solutions, including modern, more efficient biomass stoves, but also the use of biogas for cooking. And because of that, the efficiency gain is roughly a factor 3. So because of that, the overall use of biomass drops. But at the same time, new applications, including the use of biomethane in gas systems, increases. So that's why you see the trend as it is, and it's quite differentiated by region, because, of course, some regions have significant heating demand, and other regions are less so.
Thank you. Chris.
Great. Dolf, thank you very much for a very interesting presentation. I really wanted to ask something about how we should think about what is likely to happen in the future. I, many years ago, participated in Shell's famous scenario planning exercises, and I wondered whether that was a useful way, rather than establishing the conventional economic forecasting base case, whether it's useful to look at some of the key things that might change and might change the outlook. And I wonder if you had to think about that for the biogas sector going out to 2050, what would be the key potential technological shifts which might cause a change in scenario?
So there are, let's say that there is a consensus between our scenario and other scenarios that deep decarbonization means a lot more efficiency, a lot more electrification, and a lot more use of renewables, both renewable power and direct use of renewables. And that's roughly maybe 2/3 or 3/4 of what is needed. And then there is uncertainty more around, for example, the use of CCS. And also in that category, then the use of BECCS, which can have a link also to biomethane. So that is one of the things I haven't talked about. But the production of biomethane could be one of these processes where you capture CO2 and store that. I mean, at the moment, there's still a scale problem. You would only do that at large scale, but technologically, that would be an option. Then there is the question, okay, well, what is now, first of all, how much biomass is available, and what is the optimal use of that biomass? And there is a wide range of projections of how much biomass can sustainably be produced. So as I showed you, we use 150 exajoules. There are also much lower estimates of how much can sustainably be produced. And that is a discussion we continue to have. And then the question, okay, and how should you now use that biomass? I mean, when I look at developments last couple of years, we see that electrification in road transport seems to be developing very fast, not only for cars, but also for delivery vans and for heavy-duty vehicles. We see that in shipping now, there is more attention for ammonia and methanol as a solution than into bio LNG, let's say. So there are some positive and some negative elements in that can impact the biogas outlook, and maybe it's worthwhile to do a dedicated study, a dedicated multiple scenario study just for the biogas outlook, because it depends on a number of inherently uncertain factors. But as said, I mean, our estimate is it will grow significantly going forward in any scenario.
Great, thank you, Dolf. I know we've talked briefly when we last spoke about possibly doing a joint study on biogas, and I think that could be a very sensible thing for us to do. Do we have any more questions? One here, John.
So in the presentation, I have seen the price of biomethane, 90 to 110 euro per megawatt hour. I wanted to understand this price is independent of the purpose of usage. For example, if it's used for transportation fuel or heat, or how the pricing were evaluated.
Yeah, so that's a price for German biogas, a wholesale price for German biogas. My understanding is a price for the grid, and it's a forward price. So price for a contract you sign now for delivery early next year. But it's a price, it's not a cost.
Okay, thank you very much. Do we have any other questions from the floor? There's one here, John.
We yesterday heard even that it's very dangerous for the woman to cooking with wood there in Africa. And I think there is a lot of potential, and you also showed it in your slides, that there is a potential for using biogas for cooking. Do you in IRENA also think about facilitating from the financial point of view or the economic point of view to improve the situation there in Africa, because today the people, they just take the wood, this is there, is no cost for it. So if we are producing biogas there from whatever leftovers they have, and they are there, but then there is a cost for the gas. Is there any idea in that direction?
Well, we work with other parties that indeed try to develop these clean cooking solutions, or try to apply these clean cooking solutions. Because there are already so many initiatives, we thought it's not it doesn't add much if we as IRENA start our own additional initiatives. So we try to work with SE for All, the Clean Cooking Alliance, etc., to put these solutions into practice.
Thank you. Dolf, we're now out of time. That's been a fascinating presentation and a fascinating discussion afterwards. So thank you very much indeed for joining us, and I look forward to continuing our discussions. Thank you.